In a water supply and distribution system, pumps function to move water from a source to different locations within the system, providing the necessary pressure to deliver water to homes and businesses by overcoming elevation changes and friction losses in the pipes, essentially acting as the driving force to ensure a consistent water supply across the network. They do this by increasing the water's pressure and moving it from lower to higher elevations through the pipes. The power that the system requires in order to deliver water at a specific discharge must be met by the power added by the pump to the flow. How can we calculate the power that a given system requires for delivering water? Two equations are used here. They are the energy equation and the power equation. First, we use the energy equation to calculate the pump head required for this specific system at that particular discharge. Second, we use the power equation to calculate the power demand of the system using the pump head we just calculated. Because head is often regarded as an energy term for the system, it is most of the time sufficient if we know the pump head, without the actual need for calculating pump power. A system curve shows the total system head required over a range of flow rates. In other words, the system curve is a graph that shows pump head required by the fluid system at different flow rates. It is determined by calculating the resistance to flow of all the components in the system, such as friction losses due to pipe diameter, length, and roughness, elevation changes, and fittings and valves. For a given system, the system curve is fixed and does not change unless there is a change in the system's configuration or operating conditions. Now we know how to find the power required by the system to deliver water. What about the power a pump can provide to the flow? The answer is easier than you might have thought. The head curve, which is one of the most important pump performance curves provided by the pump manufacturer. The pump curve is a graph that shows the pump's flow rate, head, and power consumption at different operating points. It is determined by conducting performance tests on the pump under controlled conditions. The pump curve is specific to the pump model and size, and it does not change unless there is a change in the pump's configuration or performance. The pump curve and system curve are combined to create the pump system curve or total head curve, which shows the total head that the pump must overcome to deliver a specific flow rate through the system. The intersection of the pump curve and the system curve represents the pump's operating point, where the flow rate and head produced by the pump match the pressure or head required by the system. This assumes the pump is in a like-new condition, has no air entrainment, and is not suction cavitating. Essentially, the operating point is the point where the pump can effectively balance the demands of the system it's working against, and is crucial for selecting the right pump for a specific application. To find the operating point, plot both the pump head curve and the system curve on the same graph. The intersection point is the operating point. The pump efficiency, which is calculated using the power output from the pump divided by the power input to the pump, varies at different flow rates. When flow rate is 0, the pump efficiency is 0, since no flow or no output power is present. When the flow rate is too large to be further pressurized by the pump efficiency is again 0. When choosing a pump, aim for an operating point that falls within the pump's most efficient range on the pump curve, which is usually near the best efficiency point or BEP. Besides, there is also a performance curve named brake horsepower curve, or BHP. Brake horsepower refers to the input power to the pump, whereas water horsepower or WHP refers to the output power from the pump. The ratio between WHP and BHP is the pump efficiency. Because WHP can actually be calculated using the pump head in operating discharge, and the operating pump efficiency can be estimated once we have the operating point figured out, the BHP can be calculated indirectly, although it can also be read from the brake horsepower curve.